number of memory slots, it goes from 2 by 240 pin. I would not buy a motherboard with only 2 memory slots, because in order to expand the amount of RAM, if you only have 2 slots, your only choice is to phase out the ones that you have in the system before you put in a larger capacity memory modules. Okay, so that to me is kind of wasteful. If you get ones that have at least 4 slots, that means that you can install like 4 gig today using only 2 of the memory slots, and then later on, if you need 4 more gigs, you buy 2 more memory modules, and then you use up the other 2 empty slots, and then you can have a total of 8 gigabytes. You don't have to throw away what you have today. Okay, so I would go for the 4 memory module type of setup, with the only exception that you're trying to put together a smaller PC, so footprint is important. In that case, many of those motherboards can only have 2 memory slots instead of 4 because it takes up space on the motherboard itself. So in this case, if I don't have any particular need for space, I would just go for a 4 memory slot motherboard. When you look at memory standard, the majority will specify DDR3 at 1333 megahertz or 1.333 gigahertz. You can tell it is the majority because there are 64 of these motherboards as opposed to 40, for the next one. Typically, the faster the speed, the faster your processor can talk to memory. And we already talked about, why you have caching. Okay, it's because the bottleneck is between the processor and memory. How fast can the processor get information from memory to process, and how fast can it store process data back into memory? It depends on the price point. I think 1333 or 1.333 gigahertz is going to be the most cost-effective motherboard. As you move up the scale, the cost of the motherboard will typically go up. The other part is you have to buy memory to match it. Now, typically, if you specify a motherboard that can deal with 1.6 gigahertz, you can still use slower memory, but you won't be utilizing the full potential of the motherboard in that case. Okay, so I'll just go ahead and select. Well, let me go ahead and select a slightly faster version, which is the 1.6 gigahertz version, and we'll see what type of speed we are talking about here. PATA, or parallel ATA, is a really old standard already. Okay, in other words, there are very few devices now that require the use of parallel ATA. Unless you have a favorite DVD burner that you really want to use from an older system, there's no need to specify parallel ATA anymore. In other words, personally, I would not miss having a parallel ATA connector on the motherboard. But because the chipsets, remember the Northgate that we were talking about, most of those have a parallel ATA capability, and most manufacturers will actually bring it out. In other words, they will actually make it available. I would just specify any here, because I don't need any. Okay. So I'll just specify any here. Maximum of memory supported, we talked about this last time too. It depends on what you're doing. If you're playing games a lot, if you want high performance, in terms of playing games, having more memory does help, because basically what happens is the game is preloading more stuff into memory ahead of time, so that when you're playing the game and you're up to a certain point, it doesn't have to load the scenes or whatever from the hard drive anymore. It is already in memory, ready to be played. Okay, so that helps. If you're using virtual machines, if you're using emulators a lot, having extra memory will also help, because let's say you want to set up 6 virtual machines, each one taking up 2 gigabytes of memory. That means you will be using 12 gigabytes of memory just for the virtual machines. And in that case, you definitely want to have a motherboard that can deal with up to 16 gigabytes of memory. If you don't know what a virtual machine is, and it doesn't seem like something that you will be using anytime soon, and you're not a high-end gamer, 8 gigabytes is a lot. Okay, so unless you know that you have specific needs, 8 gigabytes is already quite a bit, and it should be more than sufficient for most people. Serial ATA 3 gigabit per second, which is an older standard because the newer standard is 6 gigabits per second. But you can also see here that with the newer standards, with 6 gigabit per second, they only have one motherboard that has 4 serial ATA connections, which means if you want to set up a RAID, this is the only choice that you have if you want to go for 6 gigabits per second. But remember one thing that we talked about already. The bus speed or the serial ATA connection speed is not the only thing that determines the actual speed of transferring data from your hard drive to the processor or to memory for processing. The other factors are the physical factors. For instance, any hard drive is a rotational device. Okay, so you still have to wait for the sector that you want to read to quote-unquote fly under the disk head. You still have to wait for the disk head to move from one track to another track. Okay? In other words, once the data is available under the disk head, yes, a 6 gigabit per second hard drive, serial ATA connection will be faster. But by comparison, the majority of the time that you spend or the computer spends is waiting for the physical aspect of a hard drive to finish. In other words, most of the time your processor is twiddling its thumbs, waiting for the disk head to move from one track to another track. It's waiting for the sector to rotate under the head, and so on and so forth. The only time you can really benefit from a 6 gigabit per second connection is when you use a solid state drive, an SSD. Okay? An SSD or solid state drive is basically based on flash memory. In other words, there is no wait time, there's no seek time for the head to move, there's no rotational delay or latency for the sector to rotate under the head. You access data instantly. That is really cool, but it's also really expensive. Okay, yep.
But you also have to worry about the
load balance
overrides.
Yep. You also have to worry about overwriting the same sector over and over again, because with SSDs, there's a limitation as to how many times you can overwrite a sector. Okay, each sector can usually only be overwritten. I think these days the standard is about 100,000 times. It's not even a million. It's only 100,000 or so. And after enough write operations, a sector will be rendered useless. Okay, certain file systems are particularly good with this sort of thing, and certain file systems are really, really bad for this sort of thing. So if you get into SSD, you really need to know what you're doing in order to get the most out of the system. Most end users would not actually need anything that fast. So if I were a normal end user, I would just go for a 6 connection with the lower speed grade, which is 3 gigabits per second. That would be more than sufficient for most people. SATA RAID, this is basically software RAID supported by the BIOS and also the driver that you install into the operating system. I do not think any one of these, except maybe the ones that are really high-end and expensive, most of these are so-called software RAID or firmware RAID. Most of this is implemented by the BIOS it's implemented by the software or firmware in the BIOS. It is not exactly hardware accelerated. It is just the program is built into the BIOS itself. You don't have to install additional software to make use of it. I would just pick any because personally I just use software RAID in Linux. Yep.
We're still talking about the microprocessor, right?
The microprocessor is already somewhat determined because we determined the socket type already. Once you determine the socket type, you can only select any one of these families of processors.
When you were talking about the 100,000 tries,
The solid state drives.
Yeah, and that happens, I'm sure, if you buy a high-grade computer system. That happens, right? And then someone has to come out and then
It's mostly for servers. Okay, SSD drives, really are mostly intended for servers, And even with if you set up a server, you still need you need a 3-tier setup with most servers. Most computer servers, like a Linux server, you can set it up so that excuse me, you can preload part of what you need from your hard drive into memory. It's called caching, but it's not the cache that you use in your computer processor. It is the disk content preloaded into portions of your memory in the system. So one part is already preloaded into memory, and then they would use SSDs as a secondary stage. In other words, frequently accessed files or databases will be loaded into the SSD because the access time to SSD is a lot faster. And then the third tier will be your actual hard drive. But since servers don't use individual hard drives, so you look at the third tier as really just a RAID setup, a particular RAID configuration. But a personal computer, on the other hand, especially like a desktop, typically does not have the necessary software component to fully utilize these 3 components to maximize the performance of the system. I would stay away from SSDs, unless the price is really good, because for $100 or even $200, you can get only maybe 20 or 30 gigs of storage, which is really not very cost effective. So we just talked about serial ATA connection. We talked about RAID. We talked about PCI Express by 16. So all of these choices only have one PCI Express by 16 or 16 lane setup. Yep.
I was wondering if you wanted to do a RAID setup, but you wanted to have it really fast, could you do a solid state and a regular hard drive? So one would be a backup of the other, like the solid state would
No, that won't help because the operation is not considered done until both drives have the content that you want to write. So that's not going to help. You can use a software to back up. You can use the hard drive to back up whatever is on the SSD, like with a nightly backup or something like that. But that means if you have a crash in the system during the day, you don't benefit from having a RAID setup. Okay, so let's move on. PCI slots, they're only up to like 3. This might have something to do with some of the earlier selections that we have done already. So we are fairly limited in terms of these connections. HDMI, high definition, is it media interface? Okay, most of these have HDMI connections already, which means it is easier to set up or hook up a computer to your big screen TV as a big monitor. How many people do that? Well, I should only put up like half of my hand, because my so-called big screen TV, which is the biggest screen of my entire house, is a 26-inch. It's a 26-inch 720p HD TV. Yeah, by today's standard, it's not really that big anymore, or is it high resolution? In fact, if anyone breaks into my house, they're more than welcome to take that TV away so I can buy a new one. It doesn't even have a tuner. This is back in the good old days, when people first came up with the HD TVs. The tuner, the digital tuner, is not a part of the digital TV. I actually need an external tuner to actually watch over-the-air broadcast. Yeah, pretty old school. But we don't even watch TV anymore these days. I mean, there's no need to watch TV. My kids, when they want to have some entertainment, they would go to Hulu, and play instantly. My daughter likes to watch what's the name of that show? The Last Airbender, The Last of the Airbender, Avatar. So she likes that one, and we can watch it